Hello everyone, this is Solomon. I'm here to explain you about the implementation of a linear search. So, linear search is nothing but in an array. If I want to search an element which is present in some nth place, so to get that nth position, the search what we do is called linear search. So this is what I have said is in our local and simple language. So I'll explain you how this works. So let's take if this is our index 0 1 2 3 4 up to 23. So these are our array elements or integers. So if I want to go check with j, so what's the position of j? I can't say directly because this index will be not shown in the program. So I want to check the position of j. So how it's gonna work? So first the pointer will come to 0. This will check, uh, and this is a, so this is not equals to j. This will go next to b, that is index 1. In this way it go up to index 9 and it will check whether j is equals to j. So if the input is j, then it will check the index. This is the address of j, so 9 will be printed as an output. So if I'm gonna give an output input as s, so it keep on checking until the condition comes to s, and then that will print 18 as the output. So clearly if we see here, if we take some numbers, so finding 37 in linear search. So first the pointer will come to 0, then this will check. So 20 is not equals to 37, so this is not equal. Then this will go to 35, then here again it checks. So this is not equal, so 35 is not equal to 37. So then it comes here 37, so 37 equal to 37. So the index or the address of 37 is here. So I'm not an exact address, it is an index. So 37 index is 2, so output will be 2, so return 2. So this is a diagrammatic representation. So let's go into a code how this code is done. So this is my compiler PyCharm. So let's see, I have already coded it. So we are defining a linear search, a comma key. So key is an in keyword which is present in defining a function. So we can keep it as key or self, whatever. So for I in range length a, so if a of I is equals to key, return I. That's what I said in our diagram. So if 37 is equals to 37, when these both are equal, then it's gonna print the index of this. So it's checking a condition, so that's why we are using for loop, because this need to be uh, continuously done for multiple times, because in the first element itself it can't be our output, so it need to be executed for n number of times. That's why we are using for loop. So for I in range, so length of a. So then uh, even binary search, if I'm gonna take you to algorithm. So binary search is nothing but it's gonna be in zigzag way. It in a linear search it's gonna be in very order. So first it will check here, then it's gonna check here, then it's gonna check here, then it's gonna check here. But in a binary search it's not gonna be in order. It might be like go to 4, then come to 1. If I'm gonna check for 40, then it may go to 4 1 2 then 3. This is not an exact order. This is very it takes little more number of cases to be executed. So the worst case of linear search is the order of n, and the worst case of a binary search is order of log to n. So the best case in linear search is order of 1. So what's the best case? If I want to check for 20, so my pointer will come directly here, check here, and directly it will print 0. It need not to go for n number of cases. So if my position is in the last case, if the entered input is in the last case, it need to check n number of cases. So this is the worst case. So if it is in the first position, this is a very good case, right? So this is the best case, and perfect case order of 1. So let's go to code back. So binary search, a, low, up, and key I have took as in my variables. So we are checking a condition if low is less than or equal to up, mid equal to low plus up by 2. So we are doing some program. So I'm multiplying, I'm dividing it. So if key is equals to a of mid, so in the middle position, so binary search is, as I said, it is different from linear search. Linear search is very easy, but binary search it need to check some condition. So key is less than or less than a of mid, then binary search this will print the values of a low comma mid minus 1. When I give an input and when we see the output, you can understand it clearly, much betterly. So while true, so this is a outlook for the user, all these things. So first, if he enters 1, we are going to do for linear search, number 2 for binary search, third for exiting outside. So we are taking an character is anything. This is an not exact thing, or you can take x as a variable, ch as a variable. Normally I take in my program ch, so here also I took ch equal to int input, enter your choice. So the user will enter linear search or binary search. So if he enters 1, then it's gonna do linear search. So then it will ask enter the array elements you want. So all the array elements what he want, he will enter here. So then we need to check array equal to list of map int input. So all this will be taken in order in an array. So key is equal to enter the input to be checked. So the value, the element need to be searched, that element we need to enter here. So when we enter the element we need to search, then it will check the condition linear search array comma key. So then this is gonna be checking here conditions a of I equal to k. So all these things it will keep on checking. Then print position is nothing but the exact position what the element is present. So in the similar way, even binary search takes place. So if we enter 3, that's gonna come out of the program, or else if we print and if we enter anything, it's an invalid, so enter a valid input. So let's run our code and check how this is gonna work. So enter the size of an array. So first I need to enter my size of an array. I'm sorry, this is a quick sort which is in the next program. So linear search, yeah, linear search. First I need to enter my choice. So first we'll go with linear search. So enter your element. So I'm gonna with 1 2 3 4 5 6 7 and 8, yeah. So enter the value to be search. So I want to go with 6. So exactly, so 6 is an output. How this is 6? So for 1 index is 0 2 1 3 2 4 3 5 4 6 5 7 6. So these all are the indexes. Here is 0 1 2 3. In this way this will come. So for the index of 7 is 6, that's why 7 is 6 is printed. So if I'm gonna enter the element what is not present in the list to be searched, what's gonna happen? 7 8. So I'm gonna search for 9 which is not in the array. So this is gonna print -1 because this element is not present in the array what we have entered. So let's go with binary case. Same thing is gonna happen, but this is gonna happen by adding two numbers, dividing in this way. So 1 2 3 4 5 6 7 8. So I wanna go with 7. So 7 it gives the perfect answer, but it takes many steps to proceed. So I'm gonna with 2 1. So I'm gonna enter the element which is not present in the array. So even it is gonna print -1. If I gonna enter 4 here right now, this is gonna give invalid input. So enter a valid input. So I'm gonna end my code with exiting outside. So my code is ended. So my code is finished and came out of program. So in this way, the linear search and binary search is done. So that's all in this video. Thank you, everyone.